Okay, good afternoon, everybody. And today we're going to move on to chapter 3 of your text, and we're going to be discussing physical evidence. Just let me get to the correct page before I start. Okay, so last time we finished discussing the actual crime scene itself, and we certainly had reference there to the presence of physical evidence and to its collection. But we also need to talk about the nature of physical evidence, what it is, why it's important, and how it figures into and the actual determination of the mechanisms of a crime and of attempting to tie perpetrators to crime. It's not a simple matter in actual fact. Physical evidence, it's anything, any object at which can establish that a crime has been committed. Physical evidence, it's an object. There's many other kinds of evidence that can be considered as well, but for these purposes, we're only talking about physical evidence. That physical evidence is important if it can provide a link between the crime and its victim and its perpetrator. If it can tell us a story about how the crime was committed and who committed that crime, then it is of particular significance. You must realize that when an investigator walks into a scene, the scene may be quite chaotic. The crime may have taken place, for example, in somebody's normal home, which is cluttered with objects of all sorts. There's many. Just imagine an ordinary home. The home is just a normal home. It's not cleaned and scrubbed every single day. There's cat hair on the carpets. There are fibers all over the place. There are books piled up in a corner. The breakfast dishes are still on the table. There are knives out on the table. There's a plethora of objects in the scene which could potentially be evidentiary. But if the investigator does not recognize their significance, then they are worthless. Likewise, if that piece of evidence cannot be properly preserved for investigation, it is worthless. And once evidence like that is lost, once it has been compromised, there's very, very little that can be done to recover its evidentiary value. And so the investigator walking into scene has to realize that almost anything can be physical evidence. And it is up to the investigator to determine that that has potential and then submit it to further investigation by specialists or whatever. There's something very important though, and that is whether or not something can be presented in evidence in a court of law is up to the judge. The judge decides whether or not something can be presented as evidence, but it is the jury, in considering the whole case and considering a verdict, who decide on the importance of that. And a piece of evidence presented in court which nobody thought was of particular significance may be selected by the jury as being absolutely emblematic. The jury may suddenly recognize the weight of a piece of evidence that nobody else did. So it's up to the jury to decide on the importance of evidence. The judge decides whether or not that evidence can be presented at all. We can take physical evidence and we can talk a bit about the common types of physical evidence, but very difficult often to classify physical evidence into particular categories. However, there's some that you will definitely recognize. Oops, sorry. Hold on. Okay, so here are some of the types of physical evidence that to consider and that we'll certainly hear about repeatedly. First of all, body fluids. Body fluids are of particular significance nowadays because they can be identified to a particular, often, not always, but often be identified to a particular individual. They can be tied to a particular individual. Body fluids are primarily blood, semen, saliva. There may be some others. Those sometimes are difficult to identify at the scene of a crime, by the way. The investigator may need some expertise in order to recognize that any of those fluids are present, and then must know how to treat them properly so that the evidentiary value is preserved. Documents at a scene may be important. Drugs, explosives, fibers, fingerprints are tremendously important for reasons that we'll discuss in a while. Any firearms, ammunition, even things like glass fragments, hairs, fibers, all of these sorts of things. The investigator may look very carefully for impressions, for example, shoe prints, that sort of thing, footprints, marks indicating entry and exit. Paint chips have very frequently been used because they can tie a suspect, for example, to a crime scene. Petroleum products, vapors, these are really significant in arson cases. Plastic bags, rubber, all other polymers, you're going to hear why we pay particular attention to those. I'll give you a particular case where this was extremely significant. There may be residues, like powder residues and things present. Those need to be collected and identified. Soil, I've told you before, soil tracked in may be from a remote source. Soil may carry with it particular information. At a scene of a breaking and entering, for example, tool marks left on a window or something, or a door, or something like this. Tool marks can be tied to particular tools. At scenes of an accident, a hit and run, for example, pieces of the motor car, such as vehicle lights, that sort of thing, number plate, those sorts of things constitute physical evidence. And then there are also cases where even things like wood, plants, vegetative matter, this sort of thing, leaves, seed pods. There is a famous case which was solved because the perpetrator had seed pods from a particular tree in his vehicle that he picked up inadvertently when he dumped a body underneath that tree. These are all constitute physical evidence, all have to be treated with the utmost care, collected and processed. So, sorry, that's a repeat. It is up to the investigating officers to collect that evidence. Increasingly, precincts rely on evidence technicians that I've told you about before, because they can be specially trained to just do that, just focus on collecting what may be physical evidence. This does often mean that a huge amount of physical evidence is collected. Again, repeat what we learned before about dealing with the crime scene. Each piece of evidence has to be entered into a chain of custody, and that chain of custody carefully maintained right through the entire analysis, right up to the court of law. So just picking up something that might be physical evidence at the scene of a crime, well, that might be useful, but it's useless unless certain things are done with that physical evidence. And the very first thing to do is to identify what that is. What is it? That is sometimes not an easy matter, and may require some considerable expertise in order to do that. But the physical chemical identity, as far as possible, needs to be established before anything else is done. In addition, think of it this way. I can have a piece of something collected at a scene of a crime. That's fine. It came from the scene of a crime, so what? Unless I am able to link that piece of physical evidence to something, the evidence has no value whatsoever. So in other words, the investigator has to take the piece of physical evidence, and that we regard as being the suspect specimen, and has to compare it. Has to compare it to something else in order to establish a tie, and that is called the reference specimen. We'll take a simple example. A murder is committed, and on the body there are red fibers. There's nothing in the house. First of all, the red fibers are collected. Well, that's fine. Now you've got red fibers. What do you do with them? Well, you look first at the scene of the crime. Are there red fibers in the environment? No. You've made a comparison. You have a suspect sample, red fibers. You've compared it to the scene. There are no red fibers there. You've already got some information. These red fibers on the body came from somewhere else. Where might they have come from? Well, the suspect is picked up, and in his motor vehicle, he has a sweater, which is bright red, and the fibers look similar to the fibers from the body. That is not proof that he committed it, but it is really suspect. You've taken the suspect specimens and you've compared them to a reference specimen, the suspect's sweater, and you have established that a possible tie exists between fibers found on the body and the suspect themselves. So in other words, the fibers and you are suggesting the fibers and the sweater have a common origin. The fibers taken from the sweater, fibers taken from the body have a common origin, and that is the sweater, which belongs to the suspect. It is not proof that the suspect did it, but it is suggestive that there may be a tie between the suspect and the crime scene. We'll take another example. Let's say, for example, at the scene of a crime, there's a drop of blood. Well, let's say a drop. There are drops which the investigator presumes are blood. Well, as we saw before, there are specific ways of testing that to see whether or not it is blood, and then of testing it to see whether it's human blood, and then of testing it further, provided you've got enough blood to do this, of testing it further to establish a particular identity. Another one, we said that we examine the crime scene for powder residues. Well, there's black powder present at a crime scene. Is that black powder from a firearm? If it is positively from firearm, what does the pattern of deposition tell you? Similarly, for example, as suspect, you may apprehend a suspect and examine their clothing and find that there is firearm residue on their clothing. What does that tell you? I've given you an example of using a fiber. All of these things, what we're doing is we're taking a specimen and we're comparing. Taking it, comparing, identify, compare, identify, compare. It's again the scientific method. You are hypothesizing each way along the line, and sometimes reject your hypothesis. Other times accept that a hypothesis may in fact be valid and use that to develop your case. Remember back to what I told you about the cases Dorbert and then Mincy. And remember that these the tests need to be accepted by the court. In other words, needs to be adjudged by the judge themselves as being valid. The tests that you perform must be accepted by the court as being valid. And even if it is a new set of tests, that's what we learned before. Even if the test is a new test, it can, in fact, be accepted by the court, provided enough scientific corroboration is provided around it, is presented around it. Once a court has accepted a method, then it is very much easier to, in subsequent cases, to present that same method to another, because you can refer back now to case law and say, this method was accepted in such and such a case by the court. This issue of comparing the sample, the suspect sample, versus standard is very important. And in fact, this is somewhere where sometimes investigators fall down. And a defense team will very, very quickly pick up on the fact that such a comparison is invalid and needs to be and can be challenged. So what people examining these specimens do is they will look at select properties of the specimen under examination and then compare them closely to their reference sample. And this has to be done in such a way that the expert is able to stand before the court, explain exactly what they did, and as far as possible, state a likelihood, a conclusion about whether or not their suspect sample was tied to the reference sample. What level of confidence can they place on that? Now, that may be very difficult. This sounds like they're calling for a statistical reference, saying this is the chances that this belongs to somebody else is 1 in 20,000 or whatever. That may not be possible. In some cases, it is. In many cases, using DNA identification, for example, we can put quite strict statistical limits on it. But in many other cases, it really is an opinion, and it is the opinion of the expert, and the strength of that opinion, the expert can explain to the court why it is that they strongly believe that this particular object must be tied to this other reference object. Even if they can't say it's 1 in 20,000, they can say, in my expert opinion, the likelihood of this being from someone else is very, very small. So let's have a look at an actual thing like something like a body fluid stain. So we go to a rape scene, and when they examine the rape took place on the bed, they examine the sheets, and there are stains on the sheet which appear to be fairly recent, and they presume that these are semen stains from the perpetrator. That is extremely valuable evidence. And when they, first of all, they cannot just say, oh, these are semen stains. It has to be established that they are indeed semen stains. There are some simple techniques for determining that. They can even determine it at the scene of the crime. That is, the semen fluoresces under an ultraviolet light. So they test the stains. Most of them do not fluoresce. They're from something else. They're from the laundry or something like that. And but there is a stain which does fluoresce. So that fluorescent stain is cut out and is taken and is tested. There are specific tests to identify semen it is tested and is positively identified as semen. Semen is very rich in DNA, and it can be submitted for analysis. The DNA is sequenced in particular ways, which we will discuss much later on. And the results can be submitted to a database. Now, here's one of the most important reference tools which we have in modern times, and that is that we can accumulate data. We can accumulate data as a reference collection. In this reference collection of DNA, there are probably now hundreds of thousands of results of DNA analyses derived from many different sources, but those are lodged in a centralized database called CODIS. And that is a national database of DNA sequence. And you can submit online, you can submit the results of a DNA analysis and see if that has ever been lodged in CODIS before. If you're lucky, if you're the investigator and you're lucky, your perpetrator was picked up at some time or another for a crime, another crime, and had their DNA taken. This happens very frequently now. Under certain circumstances, DNA can be collected and analyzed and lodged on CODIS. When the expert, when the officer in charge goes to court to testify, in the very first cases of this kind of DNA analysis, they would call the DNA expert to the court to come and testify and say how they did the DNA analysis, what they found, and what the statistical probabilities are. Nowadays, it is so frequently done, the methods are so well established that in fact, very often, that evidence can be presented by an officer, an investigating officer. He can or she can present a report prepared by an expert. If the court is in any doubt, or particularly if the defense challenges, an expert who actually performed the analysis may still be called into court. But once a method is so well established, then we can assume that the court will accept a second-hand report from an expert. So things like that, DNA, fingerprints, these sorts of things, tie evidence, physical evidence, to one particular object. A fingerprint ties to an individual as an object. If you want to think about it, a fingerprint ties to a finger, to a particular finger. DNA as physical evidence can be tied to an individual. Nobody else will have that particular sequence, or the chances of somebody having that same sequence are so remote that it can be regarded as an impossibility. There are other things as well. We're going to hear about many of them. For example, when a bullet is fired from a gun, it acquires characteristics which tie it to that particular gun. No other gun will produce those marks. We can't say what the statistical probability is, but if we think about it, the possibility of that happening is so remote that it can be regarded as an impossibility. A bullet acquires the characteristics of the gun out of which it is fired. So even though, like in the case of the bullet coming out of the gun, we can't say there's a 1 in X billion chance that this could have come from another gun. We can say the chances are so remote that we must accept that this bullet passed through this particular gun. I hope that made sense. This kind of physical evidence, which can be tied to one particular object, we refer to as individual. We say that is an individual characteristic. The fingerprints, the structure of the fingerprints is an individual characteristic. the sequence of the DNA is an individual characteristic. So are the markings on a bullet. They are individual characteristics, and it is very, very powerful evidence. So individual evidence ties evidence, physical evidence, to one particular object, even if that object is a person. So let's have a look and see how this can work. This is from an actual crime. A woman was found murdered. She had been stabbed in the neck. And this quite often happens with stabbings, that the knife or the weapon impacts on a bone and either chips or breaks off. At post-mortem, this little fragment here of metal was recovered from the wound, probably from embedded in a bone. Or they had a suspect, and the suspect was carrying a knife. It looks like an X-Acto knife or something like that. And when they examined that knife, they could fit this tip to the knife blade, the knife that was in his pocket. So this now is regarded as being individual evidence for numerous reasons that I'll point out. There are actually three particular reasons. First of all, look at the fit. The fit is absolutely true. It fits absolutely with, and this crack here where the knife blade broke, that is a random occurrence. I can take another knife blade that looks exactly the same, maybe the same manufacturer or whatever, and I can try to break the tip. I can probably easily break the tip off, but if I did that with another blade, the break would be different. It will be entirely different. Instead, here, the break, even though it's a completely random event, the two edges fit together. What are the chances that this knife tip came from a different blade? Well, we can't say it's 1 in 20 billion, 1 in 1,000. We can't say that, but instinctively, we can argue that the possibility it came from another blade is very remote. But that's not the only thing. Look at these striations here on the blade here. These striations are also produced at random. They're produced because a lump of metal is rolled when it's very hot. It's rolled between rollers to flatten it into the blade, and the blade is then cut out and shaped. So these striations here are random, and they are a result of that rolling process. They're probably impurities in the metal and all sorts of things that get squashed out and flattened. If we look, those striations match across here. They match. Now we've got an edge that matches, and we've got these striations that match. Those two things, you see how those two things have multiplied with one another to make it even stronger. There's a third thing. Have a look here. These striations here, the vertical striations, are striations that are produced as this blade is sharpened. After it's been flattened, it gets passed through grinders that grind an edge to it. And those grinders impart these random striations. And if we look, those striations across there match. So we've got three things, and they multiply one another. 1, 2, 3. Three things, three randomly imparted characteristics match perfectly on this object. And the possibility that this tip came from another blade is so remote that we can regard it as being impossible. Each of these is an individual characteristic, and the individual characteristics together multiply to create this very, very strong piece of evidence. We're going to see similar things in many different instances as we go through this course. A similar argument applies, for example, to the markings on bullets that are passed through a gun. Those characteristics are also individual, as I told you before, because they are acquired randomly. Here's another one. This is, I told you that sometimes that plastic and things like that can also be very important. Here is an instance, and this body of a young woman was recovered from the river and partially wrapped in plastic, in a black plastic garbage bag. And it's just a generic black garbage bag, apparently. But there were suspects. There were actually, in this case, were several suspects. And at one of those locations where the suspect lived, where the murder could have taken place, or the body could have been, or materials could have been taken from that house to wrap the body, etc., they found a roll of black garbage bags. And when they looked at the garbage, then here on this side here, this is the garbage bag from the roll of garbage bags that the suspect had at their house. On this side here is the garbage bag which had been used to wrap the victim's head. And when they put them side by side, have a look here. Look at these striations. These striations match. They then went to the manufacturer and they examined the manufacturing process of these bags, and they were able to get testimony as to how these bags are manufactured and prove that these striations here are acquired randomly. They vary. They'll vary, in fact, through the whole, even on the roll of garbage bags that the person had at their home. But the last garbage bag on the roll was this one here. And the suspect garbage bag, the striations match completely. This is individual characteristic. And there's a possibility that this garbage bag came from some other source and had matching striations is so remote that it can be regarded as being impossible. And the person who had these garbage bags in their home was in fact eventually proven to be the perpetrator of this homicide. So that is individual characteristic, and it is tremendously valuable, and investigators are always glad to find instances of individual characteristic like that to tie a crime scene or a crime to a particular perpetrator. But there are many crimes where individual characteristic evidence with individual characteristics is not present. And a case then often is built around what is referred to as class evidence. And class evidence, it may, in some ways, individual pieces of class evidence are often regarded as being weaker evidence. There is evidence which can be tied to a group, not to a particular individual. I'll return to the example that I used before about where I said, you know, we may recover fibers from a body which were red, and the suspect had a red sweater in their vehicle. Well, that is true, but it does not prove anything. It does not prove that that person did it, because there are many people with that sweater, probably thousands of sweaters exactly like that exist in the world. Even in the local area where that person lived, there may be many people walking around with that sweater. Not only that, that textile manufactured from that thread with those fibers may have been used for many different kinds of clothing. So that fiber is regarded as being class evidence. When such a fiber is found and an object, the perpetrator, a suspect rather, has an object with similar fibers, that is only class evidence. It is suggestive, but it is by no means proof. So this applies to many things. It applies to fiber evidence, as I explained. It applies to hair structure as well. Hair is an interesting one because hair used to be treated as if it was individual. But there have been some very, very bad cases where people were falsely found guilty on the basis of hair evidence. And scientists really feel that hair comparison, at best, provides only class evidence. It does not provide individual evidence. Things like paint chip identity are also difficult to classify. On the face of it, just think of it this way. So let's say there's a car accident and paint chips are left behind. There are many cases where a hit and run driver has driven off and investigators have been able to identify the type of paint. They've been able to identify the color of the vehicle, and even in some instances, identify the identity of the vehicle model and everything by the paint that they recover. But that is still class evidence. But let's say you pick up a piece of paint at the scene, and you eventually you find a suspect vehicle, and it has paint missing from the outside. Paint is chipped off, and you're able to fit that paint chip to existing paint on the vehicle. You may move your paint chip up from being class evidence. Many cars could have had that paint. Many models could have had that paint, whatever. You may be able to move that individual chip to individual evidence. So this does happen. Blood groups are also class evidence. They are not individual, but again, if you have enough blood and you're able to process it properly, you may be able to move it to individual characteristic because the DNA is individual. But blood groups themselves simply tell you blood is found at the scene of a crime comes from somebody with this particular blood group. And many people could have dropped that blood at the scene. Here's where class evidence can also be extremely important, and that is it may exclude somebody. You may have evidence, blood evidence is a good example for it. You may have blood at the scene of a crime which you know came from a suspect. Identify the blood group, it's A, let's say. You get a suspect, test their blood, and they're B. They are excluded. They could not have left that blood because the blood group is different. Okay, so class evidence may be used to exclude suspects, which is just as useful as identifying possible suspects. But class evidence, and especially one single piece of class evidence, very often, all that you can say is the possibility that it came from the suspect can't be excluded. Let's say in the case of the A blood found at a crime scene, which you know came from a perpetrator. If you pick up a suspect who has A blood, they can't be excluded, right? But it does not prove that that was them. The blood group on its own doesn't prove that that was them. That is class evidence. Now, it may sound like class evidence then is not very useful. It is. Class evidence is extremely, extremely useful. Here, by the way, is a hair comparison. This is, on the one side is suspect hair, on the other side is sample probably from a suspect. And they are being compared here in a comparison microscope. Here's one on one side, here's the other hair on the other side. And they look like they fit together, but in actual fact, it turns out that many people can have hair which would fit this. It is not it is not definitive proof that this hair came from this suspect. it is just suggestive. This suspect cannot be excluded on the basis of this hair that's under examination. So this is the major problem with class evidence. It's very, very difficult to place statistical bounds, excepting to say that, you know, they are fairly wide. And so in the examples that we've already had, what was the statistical chance that the hair, the red fibers we recovered from the scene belonged to the red sweater that the suspect had? We really can't say. If you have paint chips at a scene of a hit and run, what are the chances that that paint chip came from the suspect vehicle? We can't say. We can't put a statistical bound on that. There are some types of class evidence where we can do that. For example, the example of blood groups, for example. Nonetheless, class evidence remains very, very important because much of the evidence that we may gather at a crime scene is in fact class evidence. And there are many, many databases, for example, which maintain information about these kinds, about class evidence like this. And the more information, the more data we acquire about them, the closer we get to being able to place statistical bounds on the importance of a piece of class evidence. The real importance, though, is that it starts to multiply. One piece of class evidence may be weak, may be very weak on its own, but two pieces of class evidence tying a suspect to a crime scene, those two pieces of class evidence multiply one another. Start to accumulate more class evidence, all of which points back to one particular suspect. And you start to see that the class evidence multiplies with one another and ends up producing a very strong case for a particular suspect having been involved. So here's a real case. This is the O.J. Simpson case. And there was blood recovered at the scene of the murder. Those of you who do not know it or don't remember it, O.J. Simpson was a famous football player. He had divorced from his wife, Nicole Brown Simpson, and she had a boyfriend called Ron Goldman. And Nicole Brown Simpson and Ron Goldman were found very, very, very brutally murdered. They had been stabbed and slashed to death outside her condo. There was a tremendous amount of blood, but there was blood on a walkway leading away from the crime scene, which appeared to have come from a suspect who'd cut themselves during the course of the murders. This is very common in stabbings, things like this, that the perpetrator becomes wounded as well. They tested that blood. So let's have a look. First of all, the blood was A blood. That was its blood grouping. Neither of the victims had A blood, so it definitely didn't come from them. And therefore, it's strongly suggestive that it came from the perpetrator. That on its own does not tell you much. 26%, about a quarter of the population, in actual fact, have that blood. But they tested these other blood factors as well. And have a look here. There are two other blood proteins that they tested for, called ESD and PGM. And ESD is very common. It occurs in 85% of the population. So you say, oh, well, that's not worth very much. PGM only occurs in 2% of the population. And the likelihood, that's 26%, 85%, 2%. If you want the number of people in the total population have this combination, you multiply them all together and you end up with 44%. 44% of the population and have that combination. These begin to multiply together. They multiply together. And in addition, we look here and we see that only 2% of the population have that combination, have this particular blood protein. This does not exclude O.J. Simpson, but it is strongly suggestive that he may have been involved. That's not very strong. Okay, 44% can have that combination. But let's just say that other pieces of evidence began to be collected there. Let's say that in addition, there was carpet fibers found. And those carpet fibers didn't originate in either of the victims' homes or vehicles or anything. But similar carpet fibers were found at O.J. Simpson's home. Take the blood evidence and the carpet fiber evidence, totally disparate. And in your mind, multiply them. We can't put a statistical, the way we did here. We can't put a statistical count on it. But the chances of that blood combination being present, pointing to O.J. Simpson, even if it's somewhat vaguely, blue carpet fibers, what are the chances of the two things being present at the same time, pointing to the same individual? A good prosecution witness from the investigative team would be able to argue to the judge and to the jury that these types of pieces of evidence add to one another and point very, very strongly, if circumstantially, towards one particular suspect. Okay, so as I've told you, even with class evidence, as it becomes more and more closely examined, it may approach the point where it becomes individual evidence. And crossing that line there's not really a definitive point, except in the skill of somebody giving testimony. There's no particular point where we can say, right, stop being class evidence, now it's individual evidence. For example, think of our knife blade. How many striations did we have to count before we can say that that tip of the knife blade was broken from that other blade? How many layers of paint in a paint chip do they have to be before we can say this paint chip came from this car which had been repainted these particular colors this many times? This applies also to things which we widely accept as being individual characteristics. Think for a minute about a fingerprint. Why do we accept that a fingerprint is individual evidence? Nobody has ever been able to prove that no two people have the same fingerprint. No one has ever been able to actually definitively prove that. It's simply, from all of the evidence that we have collected, it seems to be that a fingerprint is an individual characteristic. But how many particular points of difference does an individual fingerprint have to have for us to be able to say, yes, that a fingerprint is definitively an individual characteristic? A clever defense attorney might be able to go to things which are presented as being individual evidence and begin to argue, no, this is not individual evidence, it is class evidence, and it does not definitively tie my client to a crime because it could be somebody else. This is particularly true where we can't put a statistical bound on the evidence that is presented. So here, for example, is a paint chip, and this paint chip they've recovered at the scene of a crime. It has particular physical characteristics. One of the things we have to be very, very careful about is that sometimes we can over-examine. So in this case, for example, they've gone and they've used a scanning electron microscope to examine this paint chip, and it gives them absolutely no information whatsoever, none. It just looks like, well, it just looks like any other paint chip, and it doesn't match to anything. It has characteristics, but they're its characteristics. Come down a step and look at it under an ordinary microscope. And now something becomes very, very much apparent. For example, have a look here on this edge here. On this edge here, there are break marks where this paint chip has been removed from the car. This could be matched. It could be matched to paint existing on a suspect vehicle. So here's an example. We can be too clever for our own good. Sometimes the individual characteristics of a piece of evidence are revealed at a lower magnification, if you like, a lower magnification, not only physically, the lower magnification of investigation. So the more physical evidence we gathered, whether it's individual or whether it's class, has class characteristics, the more evidence we gather at the scene, point tied to one particular individual and to one particular individual's environment, the more likely it is that that is the individual involved in the crime. But evidence, we have always got to bear in mind that evidence may in fact exclude people, and that it may definitively exclude them. There have been many investigations which have failed because investigators became fixated on a particular person and tried to fit their guilt to the evidence instead of fitting the evidence, letting the evidence point to who was guilty, if you see what I mean. This can be avoided if the comparison between physical evidence and the reference sample is really carefully done, and if multiple reference samples are compared. So, for example, you have 5 suspects, for 5 people who could have been involved in a crime. You do not take evidence and only compare it to material gathered from one suspect. You compare it to all of them. If you fixate on one and try and force the evidence to point to them, that will be picked up very, very quickly by a defense attorney and validly thrown out of court. So I told you about the importance of the databases. The more data we acquire about particular pieces of evidence, the more likely it is that we'll be able to point to a particular individual. And so these are some of the databases. We'll hear about more of them later on. This is one of the most important and one of the oldest. This is the Integrated Automatic Fingerprint Identification System. And this is a computer-based system. It says here 80 million entries. I would venture to say there's probably well over 100 million by now. And many states maintain their own databases. It's called, and those are just referred to as Automated Fingerprint Identification System. The integrated system is one which takes all the information from the states and puts it into a single database. It's sometimes efficient for investigators to look inside their own state first, and then refer it out to IAFIS if they don't get a hit. And this task, we'll hear more about fingerprints and how they are used later on. But identifying fingerprints depends on very, very small characteristics. Let me point to one. They haven't used it, but I'll point to one here. You follow this line here, and you see how it divides there, and then it ends there. Now that could be used as a characteristic, and you'd look to see, is that present on a comparison? Does it for numerous of those very small details, and compares the two? And if a certain number match, then you say it is a positive. It's a positive identification. That used to be done by eye. You used to have to sort through hundreds sometimes of fingerprints. A fingerprint clerk would look and compare the suspect fingerprint to references over and over and over and over again until they got a hit or not, as the case may be. Now it's done by computer very, very, very quickly. Other databases are the other really important one, still growing because it's a very relatively recent one, is the Combined DNA Index System, and that is CODIS. And CODIS maintains a database of DNA sequence from throughout the United States. And there are some international databases as well. The DNA sequencing can be performed by any competent and authorized laboratory, and those results can then be sent into the database for comparison. So the collection of DNA is a contentious matter, but currently DNA is collected from individuals. First of all, felony sex offenders are required to submit the DNA. Some other offenders, violent crime in some states, it varies by state. The other important group of people are those who say, yes, you can take my DNA. And very frequently, people involved in lower level crimes will also have their DNA sequenced, but that is by voluntary submission. They will, investigators will ask, can we take a DNA sample? If they say no, and they don't fall into something which the state or federal law says must be sampled, you can't sample their DNA. And this is very contentious area of crime investigation, this collection of DNA information, because when you collect DNA information, you actually collect a huge amount of information. There are those who say that this goes beyond the evidence collection which the Constitution permits. But currently, DNA sampling has been sanctioned by the Supreme Court, and it has been deemed to be the same as taking a mugshot or taking fingerprints, although it is not routinely taken from all arrestees. So other databases are ballistics information, and that enables investigators to identify firearms from things like bullets, cartridge casings, and that sort of thing. But that is only usually only gives the database only gives class evidence. It does not give individual evidence. Individual evidence, you have to have a gun in hand, which can be compared to bullets recovered from somewhere else. There's even a database for paint chips, and a very important database. This is actually in Canada, but it can provide make, model, the year, assembly plants for many, many different kinds of motor vehicle. They have a library of 50,000 paint samples rather. There's even a database for shoe prints. shoes are often, things like sneakers, are often manufactured in very small batches, and only a relatively limited number will have a particular sole pattern, for example. So a footprint can be compared to the shoe print database. They have 22,000, probably more now. Data. Here's one, and this will tell you make and when these were manufactured, etc., etc. Okay, so here are some real cases. Please make sure that these real cases, please make sure that you read through them carefully and understand their importance. Okay, because this can be, I can ask you about these particular individual cases. So Gerald Wallace, 1975, he was found bound and beaten in his home. All they got was one single fingerprint from the crime scene. Here's an example that has potential. It's potentially useful. They don't know that it is useful. It could have, that fingerprint that they recovered could have been from a cleaning lady or something. Who knows? But they entered it into a database, and 16 years later, somebody was identified. He had committed another crime somewhere else. His fingerprints were taken, and they matched, and he was identified and confessed. Here's another case. This is called the Center City rapist case. And he not only raped, he also murdered. And these cases all went unsolved until in 2001, there was a series of rapes in Colorado. And DNA, which had been recovered in the Philadelphia cases, which sat useless because they had no reference sample, now suddenly on the database appeared this particular sequence because this man in Colorado was arrested, and his DNA was tied to that in Philadelphia. Individual evidence and absolutely definitive. This one here is an interesting one. There was this man was hit and killed in a hit and run accident, but he had paint chips on his clothing, and there was a small piece of plastic found nearby. And they were able to submit the paint chip, the evidence, the information from the paint chip, to the automated data query database that I told you about. And it came from a Ford vehicle from 1990. And they then searched through to see which of those Fords were painted that particular color, top coat color. And they found that there was only one group, and those were Ford Mustangs produced in 1997. 11,000 were made. So these investigators then went out into their jurisdiction, and they found the two gold Ford Mustangs, 1997, in their jurisdiction. One of them had damage on it, and they were able to match the little piece of gold plastic to the damaged part of the car. It was molding on the car, and the paint, although they didn't match the individual paint chips, the paint was consistent with the chips found on the victim's clothing. All of this, look at it all, individual and class evidence, all piecing together to point in one direction, and that is towards the suspect. Okay, so we'll leave it there for today, and then I'll see you again on Wednesday.